Good evening, everybody. This is Nageswara, Assistant Professor of Physics, Government Degree College, Chindalapudi. In this presentation, we will discuss about astigmatism. This is one of the type of monochromatic aberration. So before discussing about the astigmatism, we want to remember what is monochromatic aberration. If any object is monochromatic, it is nothing but single color. The image formed by the lens is not a perfect image. This type of defect formed by the lens is called monochromatic aberration. Monochromatic aberrations are five types. One is spherical aberration, second one is coma, third one is astigmatism, fourth one is curvature, and fifth one is distortion. We know, sir, in spherical aberration, the point object is placed on the principal axis. Then the image is not a perfect point image. There is a circular shape of images will be formed at different positions. In case of a coma, the image is a point the object is a point object. It is slightly off the axis. It is nothing but some distance from the principal axis. In this case, the image formed by the lens is just like a comet shape. So this is called coma. In case of astigmatism, in this case also the object is a point object but situated far from the principal axis. In this case, the image found by the lens is not a point image. This defect is called astigmatism. We know in case of spherical aberration and coma produces blurring of images. But in case of astigmatism, curvature and distortion produces a dislocation of the image. Now, what is astigmatism? In this case, already I told you the point object is far from the principal axis. In this case, the image is not a point image. It contains two straight lines perpendicular to each other. This kind of defect is called astigmatism. This is the convex lens. This is the principal axis which is passing through the center of the lens, and Y is the point object far from the principal axis. If the light rays is incident on the convex lens divided into different zones, and one of the ray is passing through the M1 M2 plane, this is called meridian plane, whose rays are formed an image at M. This is a straight line. This is not a point image. And in case of some of the rays is passing through the S1 S2 plane, this is called sagittal plane. These rays will pass through the lens and formed an image at S. This is also a straight line. This is perpendicular to the meridian image. And at the center at point C, there is a circular image. This is nearest approach image of the point object O. So the image of the point object is not a point image. It contains two straight lines perpendicular to each other. This defect of the image is called astigmatism. So where Y is a point object and far from the principal axis, and M1 M2 is the meridian plane. So the rays which is incident on the meridian plane, the image is formed at M. This is a straight line. So the meridian plane M1 M2 is lying on the object O and principal axis of the lens, and S1 and S2 is a sagittal plane. The rays which is passing through the sagittal plane, the image formed at S. This is also a straight line. This is called sagittal image. Meridian image and sagittal image are perpendicular to each other. This is sagittal plane is normal to the meridian plane. This type of defect is called astigmatism. Now, when the screen is moved from S to M, the path of light reduces to a circle C. This is called circle of least confusion. So that at C, the image is not a straight line, it is just like a circle whose radius is very small. So that is called circle of least confusion. You see there that at C, there is a circle of image. Already, this type of image discussed in spherical aberration and chromatic aberration also. And how to remove astigmatism or elimination methods of astigmatism. There is different methods we have to remove the astigmatism. One of the method is by using the proper stop. When some proper stop is placed in backside of the convex lens, minimizes the astigmatism. So this is the convex lens. This is the line which is passing through the center of the lens, that is called principal axis. This is the slit. OJ is the object. At J, there is a point object. The rays which is coming from the object is incident on the convex lens. The rays which is emerging from the convex lens is incident on the stop. Outer rays are blocked at the stop, and central rays are formed image at Z. So this IG is the image of the object O. This is the image, this is the object. So very small narrow lines will pass through the slit, which is center of the stop, formed an point image. This is the one of the method to remove the astigmatism. And second method, astigmatism is positive for convex lens and negative for the concave lens. Already we discussed this type of images formed by the spherical aberration as well as chromatic aberration. So the combination of the convex lens and concave lens situated at a some distance also removes the astigmatism. So astigmatism can be removed by using the convex lens and concave lens. Our third method, there is one more method to remove the astigmatism in which number of lenses are formed or situated at different places also removes the astigmatism. The system of several lenses eliminate the astigmatism by adjusting their positions. This system, that is the system of several lenses, widely used as photographic objectives. This is about the astigmatism. Thank you.